this is at the bottom of page 4. Take out our highlighter again and highlight the general term Tn. And what the textbook has done is develop a pattern for finding the formula. Okay? In the sequence that we have here, you notice that you're adding 4 each time. And yesterday I kind of showed you a shortcut for finding that general term, and you're fair to use the shortcut whenever you like. So the shortcut that I showed you yesterday is you would say, okay, I'm adding by 4 each time, so I know that my slope is going to be 4. So it's got to be 4n plus or minus something. And if I choose any term to check, like if I choose term 2, well, 4 times 2 is 8. And term 2 is supposed to be 7. Does it make sense that you'd have to subtract 1 to make it work? That's perfectly fine if you want to use that shortcut. What the textbook shows is that if we look at it systematically, term 1 starts at 3, and you don't have to add 4 at all, because you're starting at 3. But when you get to term 2, you're going to add 4 once. When I get to term 3, I'm going to start from 3 and have to add 4 twice. So the idea is you could always start from term 1 and add 4 a certain number of times to get to the term you want. If you do that as an idea, term n would be 3, the starting place, and then you'd have to add 4 n minus 1 times. Always 1 less than the term you found. Now, if you distribute this 4, you get 4n minus 4, and combine your like terms, you get the same thing we got in our shortcut, right? Perfectly fine. But what this pattern allows us to do, and this is at the top of your next page, is write this out as a formula for any sequence. For any sequence, if you start off with term 1 and then add d n minus 1 times, you will always find term n. And this is your first formula on your formula sheet. So I'm going to hand out your formula sheets right now. First of all, I'm going to hole punch them for you. I had a student one year, I guess maybe you don't even need a hole punch, but I had a student one year laminate their formula sheet, and then they used it as their bookmark, since it's green, right? Wherever we ended class today, you could slide your formula sheet in, and then you come to class the next day, and since there's a green paper in your notes, you're like, oh, that's where we're going to be starting from today. So, not a bad idea to use this formula sheet as a bookmark. Did I send the right amount or short in any row? Extra in this row, extra in that row. Perfect. So let's go to example 2 here. And some of you are going to like the shortcut, and some of you are going to like the formula because you don't remember shortcuts, and that's perfectly fine. So on your formula sheet, you would have said, okay, this is my formula whenever I have an arithmetic sequence. And so for this arithmetic sequence, I could use the formula and say any term number, the general term, would equal term 1, and term 1 is 3, plus d. How much are we going up by? 7. Okay? Now, there's going to be sometimes that maybe you can't see it easily. Sometimes mental math will be super easy. It's like, oh, yeah, 3 plus 7 is 10. Super easy. Sometimes you won't be able to see it. You can always find d by taking any two consecutive terms and subtracting, right? If I did term 3 minus term 2, that should be the same every single time. Does it make sense that if I took 10 minus 3, I'd get 7? If I take 17 minus 10, I get 7. Sometimes they're going to ask you to check, is this an arithmetic sequence? And you have to make sure that they all work. Because if one of them isn't 7, it's no longer an arithmetic sequence. So our d is 7, n minus 1. Okay? And some of you will use the shortcut and say, okay, I'm going up by 7, so it'd be 7n. And then what would make it work? I would have to subtract 4. Either one of those would be perfect. Now, if you want to find term 15, that's telling you that we're replacing the n with 15. So I could go to the formula and replace the n with 15, and then it's just order of operations. Term 15 equals 3. Plus 7 times 14. 7 times 14, 98 plus 3 is 101. Now in part B, it says, which term in the sequence is 220? So there's some term somewhere that's equal to 220. Again, we can use our formulas. Okay? The idea here is there is some term that's 220 and we need to find out which one it is. So we can write 220 in for the general term, even though we don't know what n is. This is sometimes confusing for students because you're going to go to your formula, and this time I'm going to use the formula that's already simplified, 7n minus 4. And even though we don't know what n is, we know there is some term that is equal to 220. So I replace the Tn with the 220. And now I just have to figure out what n would do that. Probably not going to guess and check here, probably going to use your algebra. So you're going to add 4 to both sides. And then divide both sides by 7. And you get 32. Is that? Yes. Notice the answers for these ones are right at the bottom, so you can check right away if I made a mistake. I don't know if that's so good for me or not. And so n is 32. Which term it is? It is term 32. That is equal to 220. Okay. So I'm going to get you to circle 6, 15, and 18, and I'm going to get you to put a star beside 18 because 18 is an extra challenge. So 6 and 15 should be no problem, but 18 might cause your brain to be a little bit of problem solving, but I'll give you challenge questions as we're going.